Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. So we are going to talk about the assembly language lab, specifically to make a Pascal triangle. So here's the idea. We're going to have the user enter a number that's going to represent the row and to enter another number that's going to represent the element, and then that'll return the Pascal number. So you're thinking, what the hell is a row and an element? What the hell is a Pascal number? Okay, let's take a look at this. So first of all, a Pascal triangle starts off with the number 1. Then underneath it, you write 2 numbers. Then underneath that row, you write 3 numbers. Then underneath that, you write 4, 5, 6, 7, so forth and so on. Notice that the first number is 1. Pretend that there was a 0 right here. 0 plus 1 is 1. Pretend there's a 0 over here. 1 plus 0 is 1. Okay, 1 plus 1 is 2. Pretend there's a 0 over here. 0 plus 1 is 1. All right, how about this next row? 1, 2, 3, the fourth row. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1. 1 plus 0 is 1. So I think you can now see how this works out in terms of the creation of a Pascal triangle. Namely, it is the addition of the numbers above it, and then you form a triangle, right? Hence the name triangle, Pascal triangle. You form a triangle to get the number below that. So it's going to be the addition of the 2 numbers above will give you the number below, and so forth and so on. Okay. Now, we don't have columns per se. What we have are called elements. So this slanted column right here, we call that element 0. This other slanted column right here, we call that element 1, and so forth and so on, right? All the way, in this case, to element 9. We start off our row at row 0, and notice that however number of elements you have, that's how many rows you have, and vice versa, okay? So we want to create, actually, I should say that again. We don't want to necessarily create this Pascal triangle. We want to get the Pascal number when the user gives us a particular row and a particular element. All right, so for example, if they gave us 3 and then 1, well, row 3 is this row right here. Element 1 is this slanted angle. So if I get the intersection of this slanted angle and this row 3, it looks like that's going to be right there, that number right there. This number, if you were to extend your eyes over here, is row number 3. If you were to extend your eyes over here, that's element 1. So if they enter in 3, 1, right, for the third row and the first element, the number returned to them will be the number 3, as you can see over here. All right, I don't want to create the previous row so that I can get the 1 plus the 2 is equal to 3. There's got to be a way to determine what any of these numbers are based on the element and also based on the row. And so, aha, there we go, right there, the Pascal number formula here. The way that we figure that out is you take whatever the row is, you determine its factorial, and if you don't know what factorial is, I'll describe that in just a second. You divide that by whatever the element number is, factorial that, times quantity row minus element quantity. You're going to subtract that and then get the factorial of that. This is the equation that determines the Pascal number when the user gives you a row and gives you an element. Now, you probably already know what factorial means, but just in case, let me just remind you, or perhaps present this for the first time. The factorial is nothing more than a running product. So in this case, 3 factorial is 3 times 2 times 1, which 3 times 2 is 6, 6 times 1 is 6, so therefore it's 6. 2 factorial is 2 times 1. 1 factorial is just, itself, 1. And then mathematicians define 0 factorial as equal to 1. All right, so if I were to give you a pop quiz and say, what's 5 factorial? 5 factorial would be 5 times 4 times 3 times 2 times 1, right? So it's the number itself times 1 less all the way up, down rather, to the number 1. Okay, so that's what the factorial is. Now, what do we have here in terms of the software requirements? Create functions within your assembly program that determine the results of the following equations that are used to determine the Pascal number. So you want to create a function called factorial that calculates this. You want to create a function called Pascal number that calculates this using this equation. And obviously, the Pascal number is going to be calling the factorial function, the Pascal number function, that is going to be calling the factorial function because obviously we require the usage of factorials to be able to determine what the Pascal number is. All right, so that's the goal of our program. Now I'm going to go ahead and switch over to, here we go. I'm going to switch over to Windows, and let's go ahead and open up Visual Studio. And I'm going to create a new project. And the way that we'll create our project is in the form of an inline assembly program. And so let me see here. It says empty project C++. Yep, sounds good to me. And really what that is this C++ Windows console. So I will just go ahead and click next. And in terms of the name, this will be CS. This is my 242 class. And let's see, what is this? This is the Pascal triangle. Okay, so we'll call this assembly Pascal triangle lab. All right. And I don't like to save stuff into the repository. I have my own folder that I've created called, in the Documents folder, Visual Studio 2019 Projects. So I'm going to save it in there. But of course, you can save it wherever you want. We go ahead and click Create, and we'll begin the process of typing in the C++ code first, and then we'll type in the assembly code. So over here where it says Solution Explorer, Source Files, I'm going to right-click, Add a new item, and specifically I want to create a C++ program. It says source.cpp over here. That's fine. So I'm going to go ahead and tap on Add or click on Add. And so now my cursor is blinking over here waiting for me to type in some code. So we'll start off with the typical boilerplate code to create any C++ program. And so that's going to be include IOStream using namespace, std, and then we'll have int main, and then close curly braces, and then I'll have a return 0 at the bottom of the program. Okay, well, the first thing I noticed, let me take that away. The first thing that I recall here from our lab requirements is it looks like we're going to have a variable called element. We're going to have, element is over here. We're going to have another variable called row, right? And so it looks like we'll probably be going through a loop because when I see this, when I see a numeric pattern of either decrementing or incrementing, the first thing I think of is loop, right? So we're obviously going to be decrementing 3 times 2 times 1, 2 times 1, so forth and so on. So we're going to have to require a counter. So those are the things that I'm thinking of before I even begin the process of typing my code out, like what kind of variables am I going to need. So in terms of the declarations, let's go ahead and create the row. Let's create an element variable. Now, it looks like in terms of determining the answer for the Pascal number, we're going to have a numerator value. We're also going to have a denominator value. So I'm going to create a couple of these. I want you to parrot what I'm doing, and then I'll go back and explain why I created some of these variables. So the first thing I'm going to do is I'm going to create a new, oops, sorry about that. Back over here. There we go, numerator. I'm going to create a denominator, not daemon, denom element. And then I'm going to create a denom row element. And then just a general denominator variable. I'm going to create a result variable. And then finally, what is the factorial? And I'll just abbreviate that to fact. All right. So in terms of getting the user input section, Well, I'm going to have to ask the user a question. Now, according to the handout, it looks like it's just simply asking enter the row. Okay, so we'll say enter the row. And then we're going to get that value and put that into the variable row. So that's pretty self-explanatory in terms of why I needed a row variable. The next thing I'm going to have to do is to ask the user to enter the element. Okay, so enter the element. And then, of course, I'm going to have to obtain that value and put that into the variable element. Okay, so again, that defines what that's all about right there. All right, and then we're going to go ahead and work on our calculation. And the calculation is really where I'm going to begin the inline assembly program. So underscore underscore ASM, and then open and close curly braces. And now I can go ahead and begin to work on the functions that I want to create. And it looks like I'm supposed to create a factorial function, and I'm also supposed to create a Pascal num function. Okay, so the first thing that I'll do is I'll start working on the function. So I'll start working on Pascal number. And remember that in assembly language, you start off by creating a label, and that's what this is. This label indicates the beginning of our Pascal number chunk of code. So it's in essence treating this chunk of code like a function. You go to this label and I will run the following code. Well, what am I going to do? Well, first of all, in terms of determining the Pascal number, you know that that means that I'm going to have to get the row factorial divided by the element factorial times row minus element factorial. Okay, well, maybe I should work on the factorial function first, since that's really what I'm going to be calling, is the factorial function from the Pascal number function. So I'll do this. I'll just go ahead and type in factorial, colon, enter. Now, it moves the code back over here. That's fine. These are just labels, as I mentioned before. There's nothing underneath Pascal number. We're going to fill that in later. The idea is to go ahead and work on the factorial. Now, let me go ahead and create a quick comment over here. So semicolon is how we do comments. Assume the number to be factorialized is in EAX. Excuse me. So the number that we want to work on in terms of determining its factorial will be stored in the EAX register. Okay, well, the first thing that I want to do is, assuming that the number is in the EAX register, well, I want to compare that. I want to compare the number that is in the EAX register with 0. Because if that's the case, then 0 factorial is just simply going to be 1. 1 factorial is going to be 1. And then everything else is going to be the running product. Like if it's 5 in the EAX register, then we have to work on 5 times 4 times 3 times 2 times 1, so forth and so on. All right, so we want to be able to cover all of our bases, including if the user has a 0 factorial. Right, so what is 0 factorial? Well, mathematicians define that as 1. We want to be able to cover that. So that's our first case right here. What if we're going to be dealing with 0 factorial? Well, if that's the case, then I want to establish another, sorry about that, I'm looking at my notes while typing here. Okay, so what I want to do is I want to establish a jump to another function that's going to set the EAX register to the value of 1. So let me go ahead and press enter and type in another function called set EAX to 1, colon. What is the responsibility of this function? Well, I just simply want to move into the EAX register the value 1. That's pretty much what this thing does. And then what I'm going to do is I want to establish what the value is and put it into the factorial variable. So I'm going to move into the factorial variable whatever the contents are of the EAX register. Okay. So I'm basically moving one into EAX and then EAX into factorial. And then I'm going to return. Now, the really cool thing, oh, by the way, let me just go ahead and, before I forget, let me create a quit label. And you'll notice that there's nothing underneath the quit label. So in essence, that's the end of the inline assembly program. So we always want to place a quit down here that I can just simply call that quit. No codes underneath it. That pretty much terminates the assembly line program. All right. So when you call this label, now I can say call function loosely because that's what this set of code really behaves like. It behaves like a function. And in this particular case, this function is going to return to whoever called it. That's what the RET means. All right. So, that's something that we can take advantage of, if we need to set the EAX register to 1. Here's something else that I can take advantage of as well. Let me go ahead and press enter over here, and I'm going to type in loop fac. All right, loop factorial. And let's go ahead and create that as a label because in essence, this is going to be behaving like a function. Let's type some code and then I'll explain what this is going to do. So the first thing is I'm going to subtract whatever is inside of the EBX register, and I'm going to subtract that by 1. Now that I've subtracted that by 1, I'm going to multiply the EAX register times whatever is inside of the, press enter. So I'm going to multiply whatever is inside of the EBX register. And the way that mul works is it basically just takes the EAX register and multiplies the EBX register to it. And we'll take a look at this when we stop the code and analyze it step by step. Then I'm going to do a comparison. And the comparison is going to be with the EBX register and the value 1. Is the EBX register equal to 1? Well, if that's the case, then I'm going to jump if it's greater than, right? So if the EBX register is not 1, it's something that's greater than 1, as I've just compared over here. That's what JG represents, jump if greater. Well, where do you want me to go? I want you to go to loop factorial. Oh, so in other words, we're going to go back over here. And then we're going to subtract the EBX register times 1. And then we're going to multiply that times EBX times EAX register. And then we're going to continue to do this over and over and over again. Now, when you're finished, then we're just simply going to return. So RET. All right. So remember, I'm going to type a comment here and then I'm going to erase it in just a second. Oops, sorry, I didn't mean to do that. That's the downside of working with Visual Studio with this assembly inline program. Sometimes there's inappropriate indentation. Remember how I said first we're going to multiply 5 times 4. And then we're going to multiply 5 times 4, which is 20, so 20 times 3. Because remember 5 times 4 times 3, and then we have to do that times 2, so this will be 60 times 2. 60 times 2 is 120, and so this will be 120 times 1. So in other words, it's the 5 times 4 times 3 times 2 times 1. Then we're just simply creating a running sum. That's the whole point of our loop factorial. Take whatever is in the EBX register, subtract it by 1. So if it was 5, now it's going to be 4. Multiply the 4 times the 5 in the EAX register. Compare that to 1. Is it 1 yet? Nope. Okay, then go back over here and do the same thing all over again. All right, so the EBX register was 4. Now it's going to be 3. What's 3 times whatever is in the EAX register? Is it 1 yet? No. Go back over here and so forth and so on. We keep on doing this over and over and over again until finally, when we compare it, it is equal to 1. So then we're going to jump if greater. Nope, we don't jump because it's 1 equal to 1. So then we go to the return. And whoever called loop factorial or loop fac, then I can finally jump out of that. Okay. So as you see here, I'm setting up some preliminary functions to do these little chunks of work for me. All right. Well, now that I have that, let's go ahead and work on the factorial program. All right, so the first thing that I'm going to do is I'm going to do a comparison. Say, hey, are you 0 EAX register? Because if you are, that's what JE means. JE means jump if equal. If the EAX register is equal to 0, right? So jump if equal to set EAX to 1. That's the function that I have over here. Set EAX to 1, right? So, because what is the factorial of 0? That's in essence what I'm trying to take care of. So if I'm determining the factorial of 0, then we just simply set it as 1. We define it as 1. What if that is not the case? What if it is, when I do this comparison, it is not equal? All right, well then we're going to do another comparison to the EAX register, namely with the value 1, right? Because once again, the user could have entered 0 factorial, or I'm sorry, let me rephrase that. I may have to process 0 factorial, or I may have to process 1 factorial, or 2 factorial, so forth and so on. So based on that, what if the number that I need to process is 1? That's what I'm trying to find out. Do I need to process a 1 factorial? Well, if that's the case, then I'm going to jump if equal, right, to the EAX to 1 function. Whoops, sorry. Set EAX to 1. So it goes over here, set EAX, because what is the factorial of 1 factorial? What is the answer of 1 factorial? It's just simply 1, right? So 0 factorial is 1, 1 factorial is 1. So that I've got my two, I don't want to say base cases, but it's kind of like that. I've got my two base cases covered in case I have to process a 0 factorial or 1 factorial. Now, if I have to process anything else, like 2 factorial, 3 factorial, so forth and so on, well, then I don't have to call the set EAX register to 1. Then I've got to do something else. All right, well, what do I have to do? Well, the first thing that I'm going to do is I'm going to move into the EBX register the value of EAX, right? Because that's what I've been trying to find out. Hey, are you 0? No. Are you 1? No, then you must be something else. You must be 2, 3, 4, 5, factorial, whatever it is that you want me to solve. So the first thing I'm going to do is I'm going to move you into the EBX register. Then jump if greater to loop factorial. So I've got this other function over here called loop fac. And this guy is going to be responsible for the 2 factorial, or the 3 factorial, or the 4 factorial, ... or the n factorial, right? Any number other than 0 is taken care of here. 1 factorial is taken care of here. 2, 3, 4, 5, 6, 7, 8, 9, 10, ... that's going to be taken care of over here. And so that's why I want to do that. I want to jump to the loop factorial, jump if greater to the loop factorial. Okay, and then finally, when we have done this and when we have determined what that factorial is, well, then we're done. So if that's the case, then I'm just simply going to say jump to quit, which, as you can see here, it's this label down here, and we're done with the program. We don't have to do any more processing. So this is an unconditional jump. We call this a conditional jump. We call this a conditional jump. This right here unconditionally jumps over here, right? So there's nothing else to be executed. We go from here to here. There's no other code underneath. Program over. Okay, so now I have taken care of how to determine the factorial. You give me a factorial by putting it into the EAX register. I will take over from here. Okay, so now let's go ahead and work on the Pascal number. So for the Pascal number, the first thing I need to do is I need to determine, let's see here, let's go back to the handout. Let me see, if I have the row, I've got to determine its factorial. If I have the element, I've got to determine its factorial. And then I've got to do a subtraction of row minus element and then determine its factorial. Okay, so there's a bunch of things that I've got to take care of, which, by the way, now I think you're going to start to see why I have some of these different variables that I've created, because that's exactly what I need to, to consider, all these different values here. Okay, so let me go ahead and take the Pascal number. That's the function that we're going to be calling. And let's see here. So the first thing that I want to do is I want to move into the EAX register the value of row that was entered by the user. All right. Well, now I have to determine what its factorial is. So I'm going to call factorial, that's this guy down here, right? I'm going to call factorial. And what that's going to basically do, let me just put a comment here. This is how we do comments in assembly language programming. Let me just go ahead and say calculate row factorial. Whoops, sorry, not question mark, exclamation mark. I'll put a tab over here. So by calling this, when I move the row into the EAX register, it's in essence going to be calculating row factorial. Okay, well, once I have determined what that is, you'll notice back over here on the handout, once I determine row factorial, that is in fact my numerator. Well, once I've determined the row factorial, then I can just simply say, okay, well, let's move into the numerator variable the value that's stored inside of the EAX register, right? Because that's what factorial is going to do. This thing is going to put the answer into the EAX register, and so I just want to take that and put it into the variable that I've already established over here. That's going to be the numerator of this particular equation. All right, so we've taken care of that, and so now we've got to take care of the denominator. So when we take care of the denominator, here's what we're going to do. All right, so the first thing I'm going to do is I'm going to move into the EAX register the value of element. Because as you'll see over here, for the denominator, I need to know what element factorial is, and then I need to determine the difference between row minus element, and then take its factorial, and then I need to multiply these two values together. So let's take care of this part over here, where it says element factorial. Okay, so I'm going to call factorial. Because in order for factorial to do its job, I need to move into the EAX register the value that I want to actually determine the factorial of. And so that's what I've done over here. And so now I can call factorial so it can do its job. Well, once it determines the factorial of element, which in essence is doing this part right here, right? Once it determines that, then I can move into a variable that I've created above called denom element. Right there it is, denominator element. I can move into it whatever the contents are of the EAX register. Because remember what factorial does. It determines the factorial, it stores it into EAX, so now I can go ahead and take that EAX register, transfer it, or move it into denom element, which again is an integer variable that I have already created up here. All right, so now that I've done that, let's go ahead and work on the next part of our program, which is going to be determining what row minus element is. Then I take that factorial, and then I'm going to have to multiply it times what I've just obtained over here. All right, so what we'll do is we'll move into the EAX register the value of row. And I think you can see what I'm doing here, right? I've got row. And so now I'm going to have to deal with element. So I think what I'll do is I'll just simply move into the EBX register the value of element. All right, well, now that I've got those two, I can subtract, right? Row minus element. So that's going to be subtract the EAX register, and then we'll say comma EBX. So this is in essence basically just saying, you know, EAX minus EBX, or row minus element, which is of course what I need to do, right? So I need to obtain that value. Well, once I've obtained that value, I can determine its factorial, right? So row minus element, okay, now let's call the factorial function so that it can do its job. And so that's exactly what I'm going to do over here. I'm going to call the factorial function. Factorial. Okay, so now that I call factorial, it's going to return whatever the factorial is of this. And so now I can go ahead and begin the process of multiplying those two values. So let's go ahead and move into a variable called denom row element, whatever the contents are of the EAX register. So let me do this over here. I'm going to say this is really, this is still one chunk of code here that I want to think about it. I want to think about this as one chunk of code because in essence what this is doing is it's saying, okay, determine what the row is, subtract the element from it, then determine the factorial, and then we're going to place that whole thing into a variable called denom row element. And so, because that's what this is, right? It's the denominator, but it's the row element part of the denominator that I'm about to multiply times the element part of the denominator. Okay, well, now that I have that, I'm going to move into the EAX register the denominator element variable, which is this guy right here, right? And I'm going to move, into the EBX register the denominator row element, which is what I just solved over here. So in other words, I'm moving this into the EAX register, I'm moving this into the EBX register. All right, well, now that I've done that, I can multiply them, and you do that with the mul command. And so the mul assembly command basically is going to multiply the contents of the EAX register times the EBX register, and it's going to place the answer into the EAX register. Now, it doesn't say anything about EAX, but that's just what it does, and I will show you that in just a moment. Okay, well, now that I've done this multiplication, this whole thing is really now my new denominator. It is the product of this times this. Okay, so that's what I'm going to do over here. I'm going to move into the denom, which is denominator, into the denom variable, whatever the contents of EAX are. Okay, so let me put my cursor over here and move that back over here. And that's why I created this denom variable. So now this is really the product of this times this. Perfect. And now I've got that ready to go. Okay, so now that I've moved into the EAX register, or into the denom rather, now I can go ahead and perform this division. Now here's the thing, when you do division in assembly language, you have to make sure that you clear registers, specifically the EDX register, because it takes into consideration the div and the mod. Like for example, if I said, what is 5 divided by 2? I'm just going to, don't type this. If I said, what is 5 divided by 2? Well, the div of that is going to be 2, right? So div is going to be 2. And the modulus, that is the amount that's remaining, is going to be 1, right? And so the EDX register keeps track of that. It says, okay, so if I were to divide 5 divided by 2, what is that evenly divisible into? Or how many times does 2 evenly divide into 5? Well, the answer in this case would be 2. And is there a remainder? If there is, that's basically the same thing as the modulus. Right? What is the remainder? And so we need the EDX register to store that. That's just, how this works. Okay, so before we do that, what we do is we do the exclusive OR of the EDX register with the EDX register. What is that all about? You know what this does? It clears the registers. That's what this thing does. Okay, so I'm going to type some stuff, and I don't want you to type it. I'm just typing it here so that you can see this part of the lecture. All right, if I have an input A, and if I have an input B, and let me create a little barrier right here. And if I said, okay, what is A exclusive OR B? All right, and so let's let A be 0 and 0, and let's put a barrier over here. And guess what? When the numbers are the same, then the output is 0 or false. And then let's consider this next value right here. When the numbers are different, when A and B are different, which in this case A is 0, B is 1, then guess what? The output is 1. All right, and so then if I have 1, 0, then those are different. So that means that the output is 1 or true. And then finally, we have the situation where A and B are both true. Well, if that's the case, then look at this, the output is false. So notice that when the inputs are the same, the output is false. When the inputs are different, the output is true. Okay, that's the beauty of the exclusive OR operator. So what we do is, if I want to make sure that the EDX register is cleared, I do an EDX with itself, or I do an exclusive OR with itself. Because if they are if they are the same, then I want the output to be 0. I want to make sure that everything has been zeroed out of the EDX register. So that's basically what this thing does. It just simply clears the EDX register. So now I can put data into it. Okay, so let me get rid of this truth table and go back over here. And so after, whoops, sorry, remind me later. Okay, so after our EAX register, what I'm going to do is I'm going to move, or after I exclude or the EDX register, I should say, I'm going to move into the EAX register whatever the value of numerator is. And I'm going to move into the EBX register the value of whatever the denom variable is. Then I'm going to perform a div EBX. And that's just the way you use the division mnemonic to basically say what is EAX divided by EBX. Implied in this is that you are going to say EAX divided by what? EBX, ECX, EDX, some other number. Automatically, the division takes into consideration the EAX register. Okay, so we're just basically saying what is the numerator divided by the denominator. And then once we have that, we are going to move that value into the result variable that I've created up here. I'm sorry, I've created that over here, result. And so we're going to take the contents of the EAX register, which have been determined or updated by the div mnemonic, and we're going to put that into the result variable. Well, now we're done. So we do an unconditional jump to the quit label. And as I've mentioned before, the quit label doesn't have any code underneath it. So we are done. There's no more execution of code that has to occur. And let me check my notes. Okay, so we're done in terms of the inline assembly program. So let's see here. That began right here. And so let's go over here. It ends right here. So after, right, I'll put over here a comment. This is the end of assembly inline program, right? Assembly. And so now I can go ahead and print out the results. And so that's basically going to be the output portion of my code. So that'll be a cout statement. And we'll say, and let me just make sure, according to the notes here, what is it supposed to look like? Oh, the Pascal number is, and then whatever that number is. Okay, so we'll say the Pascal number is, and then I've already obtained that because I moved that value over here, that is. I moved that value into the result variable. So result is what contains the value. And then I'll just put an endel statement so that we go to the beginning of the next line. All right, and I think that's it. Let's see what happens. So let me save my work. And sometimes this happens, so I just simply say reload all. Hopefully that reloads everything correctly. And then I'm going to, if you want to, you can build this before running. So I can click on build the solution. And down here, I'm looking for a build succeeded. Uh-oh, build failed. So something's going on over here. So let me just double click over here. And it says, mocks. Move. You guys probably saw that when I did this mistake. So I'm glad I made this mistake because it happens to me all the time. It's probably going to happen to you. And this is just part of the debugging process. This is me typing sloppily, and that happens sometimes. All right, so let me rebuild. And let's see if, oh, we got another failure. Okay, let's see if you guys probably did, I did it again, mocks. That's supposed to be move. And here's another one over here. Now, typically, I don't like correcting a bunch of these errors, but since I see them and I recognize what that issue is, I'll go ahead and do that. I don't like taking care of them in a block manner. I like taking care of them one by one because it's a process of elimination. But it's right next to it. I can see that it's supposed to be moved, so that's okay. All right, let's go to build and rebuild. And let's see what happens now. Uh-oh, I got a failure. Okay, so let's see here. It looks like something's going on over here. So let me just double click this over here. And what does it say? It says that this thing is unreferenced. Ah, okay. So I'm going to go back to my program here. And let's see here. Yeah, it is unreferenced. It's just Pascal number, and I don't necessarily call it. I don't call that particular label, so I don't see why that should be a problem. Let's see what the next error says. All right, so over here it says set EAX21 was undefined. Okay, set EAX21. Did I misspell that? So set EAX21. Set EAX to 1. Yeah, that's the same thing. So let me just double click on this, copy, paste. Oh, I did a misspelling. Let's see, let me undo. Oh, set EAX to none. Misspelling. So let me copy this, paste over here. Let's see what happens now. Build, rebuild, and all succeeded. Nice. Okay, so this warning is simply saying that you've created a label that indicates, the beginning of a chunk of code, but you never called Pascal number. I do that just in case in the future, perhaps I want to call this particular function. In this case, I didn't, so I could have gotten away with, not having this label here, but it's just a warning. It's not an error. An error, the program won't run. So I think we're okay here. All right. Well, I'm just gonna run the program just to see if it works. And so I'm going to have the command line output that will display. And let's see. Let's go back to my handout. It looks like I entered 3 and 1, and the answer should be 3. So let's see here. I'm going to enter 3 for the row and 1 for the element, and the Pascal number is 3. Cool. Let's see here for something else. How about maybe I want to get that 84 right there. So it looks like the row for the 84, the row is 9 and the element is 3. So if I enter 9, 3, it should give me 84. So 9, 3 should give me 84. So 9, 3, and it gives me 84. Nice. Okay, and I'll do one more test here. Let's say that I want to get that 36. So that'll be, let me choose a different row. How about this row over here? So this will be row 8, and element 7 should give me an 8. So 8 and 7 should give me an 8. So let's run the program again. 8 and 7, and it gives me an 8. Wonderful. Okay, so our program works, but really what I should do is I should stop the program so that we can take a look at it and work through this step by step. So what I'm going to do is I'm going to place a break right here. And then I'm going to jump to that code. Let me close the door really fast because I hear somebody jackhammering. And I don't want this to pick up on the... Oh, my wife is closing the door right now, so hopefully that sounds a little bit better. Okay, so now I'm going to run the code. And we're going to stop the program here. So I'll just enter the 3 and I'll enter the 1. And now we've stopped the code over here. So I'm going to take that value of 3 and I'm going to move that into the EAX register. But before I do that, you'll see that I have, let's see, maybe I don't have the tab over here. Sorry, so I can do that with you. I can click on Debug, go to Windows, and I'm going to take a look at registers. So I'm going to click on registers. Now, I don't know how registers is going to display for you. It could be floating over here. For me, it was, docked over here. So I'll just do this over here. I'll just put it on top of that semi-transparent rectangle, and you can see what it looks like. Or I could have taken this, and I could have, let's see, I think if I move this all the way to the bottom right here, I could make that a tab. So now I have memory, autos, locals, registers, and that's really what I wanted to take a look at because I need to take a look at the EAX, EBX, ECX, EDX registers. So this is the way that I can do that. Right now, there's just garbage in there. When I happen to run this program, this is what happens to be at this particular memory location. The EAX register is a memory location. Well, I shouldn't say it's a memory location. It is a register within your CPU that has random data. That's a better way of saying it here, or more accurate way of saying it. I have no idea what data is going to be in there. When I turned on the CPU, this just happens to be in there right now in the EAX register. That is about to be replaced with whatever the value is of row, which in this case is 3. So when I step over, notice that 3 is placed into the EAX register. Now, just so that you know, this is the hexadecimal representation of a number. Now, it just happens to be that 3 in hexadecimal is the same thing as 3 in decimal, so that's why it doesn't look any different to you. But if you're going to rerun this program, if you type 10, then this should be the letter A, because this is the hexadecimal representation of a number. Okay, so what we are about to do now, remember, anything after a semicolon is a comment, so ignore this part right here. It's the first two words that we have to focus on. We are going to call the factorial function. So let's see here. I think I may have to click on step into. So let's say step into. Yep, sure enough, I stepped into the factorial function, right? Let me go back over here and show you what we did. We called the factorial function. So this jumped all the way over here to here. I shouldn't say jump, it called, because jump means something in assembly. All right, we are now inside of the factorial quote function, close quote, part of our assembly program. And what am I going to do? Well, I'm going to take that EAX register, which I know is 3, and I'm going to compare it with 0 to see, hey, am I trying to determine what 0 factorial is? No, so I do that comparison, so I'll just jump over, and it's going to say, hey, jump if this comparison was equal. Well, they're not equal. This is 3, this is 0, so therefore I will not jump if equal, so watch what happens. We go to the next item. Okay, do a comparison of the EAX register with the number 1. All right, so we're going to do a comparison. Hey, jump if that comparison was equal. Well, it was not equal. This is 3, this is 1, so it's going to ignore that command. It's going to go to the next command, which is my assumption that, well, I shouldn't say assumption. I know the number is not 0. I know the number is not 1, so it's got to be 2, 3, 4, 5, something else. Well, in this case, I know it's 3. So the first thing I'm going to do is I'm going to move that number into the EBX register, which as you can see is, who knows what that is. It's just some random number that's in there. So let me go ahead and step. Now the EBX register has the number 3, as you can see over here on my registers panel. And if I hover on top of that as well, you can see the number 3. All right, so what are we going to do? We are going to jump if greater to the loop factorial function. Well, jump if what is greater? Well, jump if the comparison is greater. See, inside of the EAX register, I have the number 3. Okay, so we are going to JG loop. All right, so let's see what happens. I'm going to say step into, and so now we are inside of the loop factorial. All right, so now that we are inside here, notice that the EBX register is 1. I'm about to subtract 1 from this. So what happens? The EBX register now is 2. It was 3, as you'll recall. I'm going to multiply EAX times EBX. Now, I know you don't see the EAX over here, but that's exactly what's going to happen. It's going to take these two, and it puts the answer right back into the EAX register. So when I step over, there it is. It took the 3 times the 2 and now replaced the 3 with the 6, because 3 times 2 is 6. All right, now that I have that, let's do a comparison of this EBX register. Hey, are you 1? So let's see right here. I'm going to do a comparison and then ask the question, are you 1? Because if that's not the case, right, if you are greater, if this comparison results in greater, then we're just simply going to jump. And as you'll see over here, this is 2, this is 1. 2 is clearly greater than 1. So what do? We go right back over here. So let's go ahead and I'll do another step into, and sure enough, we're just went right back and ready to do this process again. So I'll take this EBX register, which as you can see is the number 2. I'm going to subtract 1 from it. Okay, so I've just subtracted 1 from it. So now it's 1. I am going to multiply the contents of the EAX register times the EBX register, which in this case is going to be 6. And it's going to put the contents right back into EAX register. Well, nothing happened because 6 times 1 is still 6. All right, now I'm going to compare the EBX register with the number 1. So these two are now going, if I were to say, hey, compare those two, well, they're equal. Okay, well, this says jump if greater. Well, they're not greater, they're equal. So notice what happens. It skips over that line and it goes to return. Well, return means go back to whoever called me. Well, who called me? It was that factorial that called me, and so now we're done. I should have done the step into. So sorry about that. I want to do this again so I can make sure to show you step by step what's happening. So 3, 1, and then let me just step over. Let me step into, and let's see here. Okay, so we're going to do this. I should have said step into. And actually, I can just simply click step into. All right, and so now we are here. Okay, so we're at return. So now I'm going to say step into, and oh, it's the same thing again. Okay. We're going to move the EAX register into the numerator. Oh, I guess because we solved for EAX. That's just simply 3 times 2. Sorry about that. Okay, so now we're going to populate the numerator variable, and so now you can see the numerator is 6. So in essence, what we've just done is we've solved this part right here. Now we're going to start working on the denominator part. Solve for this, multiply those two, and then we'll do the division. Okay, so that means I need to, over here, what do I need to do? I need to determine the factorial of the element. So first, let me move that into the EAX register, as you can see over here. Now I'm going to call the factorial, so I'm going to say step into. So I need to determine what the element factorial is. All right. Well, first of all, let's do a comparison. EAX1, EAX is 1, I should say. Is 1 the same thing as 0? No, it's not. Is 1 the same thing as 1? Yes, it is. So that comparison was equal. So now notice we're going to jump if equal to set EAX to 1. So I'll go ahead and click on step into. Sure enough, here we go. We're going to move into the EAX register the value of 1. And then I'm going to move into factorial, whatever the value is of 1. Okay, and so if I hover on top of factorial, you'll see that right there. Okay, so then return, so I'm going to go step into, and so we've just called factorial. Now I'm going to take this guy right here, which is the 1, and I'm going to move that into the denominator element variable. Okay, so I've just taken care of this. Now I've got to find out what row minus element is and then determine its factorial. Okay, so I got to get the row. I'm going to put that into EAX. Get the element, put that into EBX. I've got to subtract those two. So what is EAX minus EBX? So what is EAX minus EBX? And put the answer right back into EBX. So that's why you see the 2 over here, because the 3 minus the 1 is 2. So now that's in the EAX register. Now I can call the factorial function. All right, so let's step into that. All right, so it looks like the EAX register is 2. Are you 0? If I do a comparison, are you 0? No. If I do a comparison, are you 1? No. All right, well then in that case, let's take what you are and move it into the EBX register, because then because then I'm going to, if you're not 0, if you're not 1, well then I'm going to jump to the loop factorial. And so I jump into the loop factorial. Okay, so I need to determine what 2 factorial is. So that's going to be 2 times 1. So I take the EBX register, subtract it by 1, and then I do a multiplication, and then I do a comparison. So EBX register is 1. I'm comparing it with 1. This is equal, so therefore I'm going to jump over this and go to return, and then now we're back over here. I take what that EAX register is, and I put it into the denominator row element variable. Denominator row element variable. So in other words, if this is 3 and minus 1, that's 2. 2 factorial is just 2. That's why I put the number 2 into here. All right, well now I can take this and multiply it with this. And so that's what this next chunk of code does. So we're going to move into the EAX register, this part right here. We're going to move into the EBX register, this part right here, and then we're going to multiply them. So notice over here for the EAX register, What this does is it takes EAX times EBX and puts the answer right back into the EAX register. Okay, so, well, now I have my solution for the entire denominator. So I'm about to take that and put that into denom. Okay, so now that I have that, let's clear the EDX register, which is basically what the exclusive OR of an EDX register does. Now you may be saying, hey, Professor Solis, it's already clear. Yeah, I understand that. You still have to do this before you're gonna use the div. You've got to make sure that you clear this. All right, so I'm gonna go ahead and do this. Now I know that it's cleared. I'm going to move the numerator into the EAX register. There it is. I'm going to move the denominator into the EBX register. There it is. And now I'm going to perform a division. Okay, so let's go ahead and perform the division. So notice what happens. Okay, so obviously 6 divided by 2 is 3. So that's it right there. It's 3. And if I wanted to find out if there is a modulus or a remainder value, that's what the EDX register would show me, and that's why I have to clear that out. Okay, I've got that value, so let's move it into the return variable, which, there's garbage in there right now because I haven't assigned anything to it. So I'm going to go ahead and assign the value now. So the result is 3. And then finally we're done. So notice how it just jumps to quit, which now we're back into C++ mode, which is simply to evaluate or to send out the value of result. And so I'll just go ahead and click continue at this point. And then I'm going to switch over to the output. There it is. And sure enough, the Pascal number is 3. Okay. All right. So this is how you would troubleshoot your program. This is also a video lesson to make sure that you understand the idea of using labels to declare or to basically show the beginnings of a function. And you want to make sure that at the end of your function, you are jumping out of that function, whether you're returning to something or whether you're unconditionally perhaps jumping to something. You see how I've done that. And then at the very end, I always have a quit because that's the last thing to do. And so when I'm really done with my program, I can just jump to this. There's no code underneath here. So we're done. And you can see how this is like a big umbrella. This is a smaller umbrella underneath the bigger umbrella. And this is a tiny umbrella underneath the little umbrella. So I always try to think from big picture to smaller picture to smaller picture, right? So this is a small chunk of code that is required by this guy. And this is a small chunk of code that's required by this guy. Maybe that's one way of thinking about it. Or you could just simply say, okay, this is a big chunk of code that requires this. And this may not necessarily have anything to do with this, but certainly it's, these two separate functions help me to determine this. So that's another way of thinking about it as well. And then, overall, well, we've got this big main part of the program over here that is responsible for the overall idea of determining the Pascal number, which is going to get the row factorial divided by the element factorial times row minus element quantity factorial. And then that determines the Pascal number, which is any of these numbers given the row and the element. And that's it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.